And I'll be live. Yes, we have been live like 9, 10 seconds. Yeah, GM, everyone. Hope you can hear me. I yes, sound check. Good to go. Okay, so today we're doing something a little bit different. My God, the music in the minute time. Let me see if this I can use. Yeah. So let me just wait a couple of minutes to broadcast this and see how people join the stream. Minutes. Yeah. Sorry about that. Okay, let me share. This is still a work in progress though, but let me share in the meantime. This is what my team and I at Solana Turbine Accelerated I've been working on. So let me do this, share this. Aha. Yes, so this what I this move this. Yeah, so this is what we've been working on. Hold on. Yeah, we got to get the full gist, but let me get as much people on this stream as possible. Mm, to- One minute, 1 minute. Is there not? Oh, close the chat. So there we go. Okay. Mm, 1 minute. Still trying to get people in. Discord. Yeah. Yeah. Not. Yeah, I think we are good to go. Spend 5 minutes already. Uh, okay, so GM once again, and welcome to today's episode of the Anchor Founder. Let me put that up. Okay. So today, what we'll be doing is we'll be sharing what we've been working on for a while at Solana Turbine Accelerator Builders. Right, it's like more of like spilling the tea before the official demo of the project, right? So yeah, so let me just share a an high level overview of what we've been doing, and I want to say a big shout out to all the contributors on this project. Let me share the link. Moment. There's big shout out to Ajish, to Gojand, to Shubham, to Emmanuel, to Mahmoud, Vito, to Indra and Kuldeep. So those guys have been amazing working working our asses off trying to pull this off. So let me just show you what we're building. Let's start with from the rough overview, right? So you might want to buckle up for this. Scalidra and why we're actually building what we're building, right? So let me pull up the Excalibur where it all started from. Let me reduce volume of this. It's getting too loud. Okay. Yeah. So this is what we are building. It's a lot, but not so much. Let me share this back. Yes. No, no, no. I want to share this screen, not that one. Yeah. So this is what we have been building. And I remove this, take this down, minimize this, uh, remove this. Okay. Yeah, much better. This is the overall thing that we built. So we built um, an SDK that wraps around interacting with Magic Block for building games, right? So it is you're building a game on Magic Block. You know the whole works, right? Delegating, committing to the ER, on delegating the whole works. So that's what we proposing an SDK to solve. So for game developers, right, what most game developers just want to do is I have a game. I just want to build a game. Let's say there is an example, there is in Bevy, right? I have a game where a character shoots whatever game that you're building. So the most important thing, or one thing you want to store on chain, if you have an on chain game, apart from your program logic, your game logic is the states, right? States will be in account. So instead of trying to understand how serializing and deserializing accounts work as a normal game dev, let me show you what Rush. I think it's a Rush. Yeah, Rush Magic Block. So it's the SDK that Magic Block provided. So Alpha did the program with that. Magic Block. Let me just go to the Magic Block repository. Magic Block. Magic Block. Show you what Magic Block is doing for game developers as an SDK and as a framework, not an SDK, as a framework, and that should be in tools. Then we have both. Okay, not Rush. Rush is for Sonic SVM. So both is Magic Block. So yeah, so this is what Magic Block is. Let me show you an example of how it looks like. First, the disclaimer is to build a game or an application on chain, you need to familiarize yourself with Solana program smart contracts, and you might be already familiar with Anchor. That means you need to know what Anchor is. You need to know how to build programs with Anchor. A game developer does not necessarily want to know how to write programs. He just wants have a game. How do I put the game on chain? Straightforward, right? Yeah, so that's basically what we're trying to solve. So one of the most used toolkits. So both is a framework that extends Anchor functionality. So it's a framework that's built around Anchor, so to say. So you need to know how Anchor works, account stuff. So it is built into ECS, entities, components, and system. Basically, let's get into that right now. Let me show you an example of what a boat project looks like. So you have this anchor declare ID here. Then you are creating a position copy. So let's see what that does. Components are plain data structures, classes or structs that contains data relevant to specific aspects of an entity. So if you want to store your position of an object, let's say you can move in X and Y axis, right? So yeah, so that's what the component is. Then you create a system for it, both system add, both system movement, execution. So you have all of that. Let me see. Let's keep going. All program overview. Yeah, so both is like you're writing your own program that handles how your entity should look like on chain. So that's what both is. So adding an entity and all and all and all and all and all, right. So that's what both is trying to do. So how about we abstract even further? So without you needing to know about Anchor and all, and you can still be able to build on-chain programs. I'm looking for an SDK. One simple example, there a live demo. Signature, an identity. Yeah, so it's basically creating an entity, adding the entity, but there's no, if I can get around on a live demo, you can break it down further. So they have a Unity SDK also. But yeah, that is the whole works on how it works with on how things are implemented in both. But for our use case, we are creating a unified API that can just create world, read your world state, write your world state, and also create your world state. Let's expand this functionality a bit. Let's do a create state also. Create world. So this one should be create state. So there's a create world and a create state, right? Yeah. So let me map this to this. And I'll do one more. Yeah, from here over to this. Yeah. So we have a create world. We have a create state. And what is a world? A world is your world, basically. Your global state, your global instance that every other thing you are spawning on top of lives in. So that's what the world is. Just like a global identifier that says, okay, this is my own partition. in the whole entity component system framework. So this is my own instance of the word. Basically, this is my own earth. So this is my own earth, and everything, all the rules that I want, I would specify. If I don't want humans to move on two legs, I don't want humans to move on two legs. They move on four legs. That's it's your world, right? So you can create whatever you want inside of your world. Then you can create states inside your world. You can write to the states. You can read the states on chain. Right. So that this is basically what we try to solve. Then we have an SDK, and an SDK points to our program. So the program is where all the magic happens. Right. So the program does most things, but the SDK is where the magic happens in inside of these two components, not just one place. Magic is happening everywhere. Actually, magic is happening everywhere. Yeah, I'm building magic for magic block. Yeah. Let me just get to it and stop rambling. So that's basically the whole thing. Everything you see here, all this mind map thought process, we built it into one single unified API. Yes. So what are we building today? There should be a demo to show how this works, right? So let me open up. Okay, before then, let me find the GitHub repository where this lives. The Mojo. Yeah. So this is where our program lives. So let's start from the program. Right. So what's going on here? So this is Pinocchio. This is Rust, basically Pinocchio. And let me try to see it to show my face. Yeah, that's me. And let me enter. So the cargo terminal is basic, apart from the dev dependencies. Rising Pinocchio system, Pinocchio tokens, Pinocchio pub key, logger for debugging, then assisted token account to be I've not using this currently. ByteMock. So we're doing a whole lot of ByteMox gives this convenience when writing Pinocchio, serializing bytes, writing to bytes, reading bytes, and having a structured layer of what you're expecting, right? Then there's the ER, the magic block. So let me just get into how it's structured and the whole magic that's going on here. So we have our librs and we're basically just doing one, two, three, four, five things. Creating an account, everything is an account on Solana, right? Creating an account, we are delegating that account, committing states, the are committing any changes that we've done. So if we update the account that is delegated, we commit the states to the base layer. And when we're done, if for any reason we want to undelegate back and give the control back to the base layer, that's it. So it's basically what you would do with Magic Block, what the typical thing you would do with Magic Block, right? So source and yeah, so what makes all of this possible is inside state. So this is how should I start with the solution first if I go to the problems, or should I start with the problem if I go to the solution? Whichever way is the chicken and egg thing, I'm going to end up there either ways. So we have this general instruction handler thing. I am going to remove all this. This was the old method we were doing, but we later fixed that, right? So this is what is happening in the generic instruction handler. We have a struct that is plain old data, zeroable, clonable, and debug if you want to copy partially. So we have these seeds. Every account, you want to create an account, you specify the seeds for the account, right? So the seeds and it is of length 32. So it's basically a pub key, but not a pub key, but it's the size of the pub key, right? That's basically what the seeds will be. And we need to specify what size this account would be. So we need to know what size this is not an account basically. So this is the entry point, instruction entry point. So we need to specify what size this instruction entry point is. So how we're doing it over the surface is we have, let me go back to Excalibur. So we have this big blob, right? This is our instruction that is going to our program. So this is the, let me do it this way, instruction, let's leave that way. And this is our program. Let's call this our program. This is our module program. This is our module program. And for every instruction, right, every instruction is basically just bytes now. Everything you're sending to your instruction handler is U8, U8, and whatever length the whole instruction is. So let's say it's 112, 123, 125, what length you are using. So len, let's put that as len. So that is basically what is being sent to your program. A byte is an array of bytes, basically array of U8 bytes. So what we are doing is we have this first byte as, so this will be the instruction discriminator. So this one is the instruction discriminator RX discriminator. First byte is instruction discriminator. The next byte is our context, our magic context, not magic, but follow. Let's again a little bit. So this one is it? This next one is, yes. This next one is, okay. Let me map this so that this is the instruction discriminator. This next one is the size of our instruction. So that size of instruction, the size of the account of the seeds that are passing to the instruction handler. But if we come into source, come into instructions, check out create account. So we are getting the general instruction handler struct. Then these are the accounts that are passing from clients. Then we need to know, where does module useful data start from? So it starts from where the discriminator has been cut off, right? So this is where discriminator, we remove the discriminator from the general instruction handler. So the length of our data, so whatever data we're passing that is meaningful data for us, which is of this struct. So the meaningful data that we are sending from the client or wherever in the instruction, we need to know what the length is. So that's why we included this length property here, which is just the size of this guy. So we need to know where it's starting from and where it's ending to know the size of the bytes, the structure, right? The whole length of the bytes, right? So that's what this is for. This was the first. This is uh, just disturbing that I'm looking at. When you look at your old code and you're like, I should have removed this. This we're no longer using this. But the idea here previously was you are passing all the bytes. So the first byte will be a string, the second seed, the first seed will be a string, second seed will be a string, third seed will be a pub key, fourth seed. So you are only restricted to 5 seeds that way. But now we've done something brilliant. So we are using SHA-2, that's 256 encryption, hashing. That's basically the way a pub key is created, basically under the hood. So we're doing that in, so do I want to get into the rabbit hole of how that's happening? Let me see. Where is that code? Is it in states? I think it's in states and it's in mod rs. I think no, not yet. Source. Then constants. I think. Nope. Uh, librs. Librs. It's in okay, it's in the test, not in the program itself. So it's in the test, source libars tests. This one, this something so it is. I think your pipe. Yes, and code pack is one of them. Then the other one is yes, compute hash. So compute hash just it takes all the seed you pass into it, how long it is a vector of 8 bytes, right? Or vector of bytes, u8 bytes. Then it hashes it and returns whatever you sent to it. So that's what compute hash does. So that's how we are now handling the seeds now. Instead of fill first, fill second, fill third like you saw earlier. And now using this encode pact also, it is just whatever amount of seeds you pass to it, it does this combine dot extend from slice where that's the combine this vector. So you just extending the slices on top of it and returning combined. Uh, I think that's basically it. Let me see. Yeah, I don't think I'm missing out anything else. Let me check the test. The first test was this mod without the ER, but this was removed. Tests. Then let's get into test for ER. So this other one was the unit test. Then this is the test on chain DevNet. So like I said, so whatever seed you want to use now, you just pass it in here. So if I'm using the bed, a string called Birdy, and the pair pub key as strings, will encode those seeds, encode packed. Then we'll compute the hash of this combined. So it extends it as slices. We saw how what that is doing under the hood, right? So we compute the hash of the encoded seeds, and we're using the payer pub key again as another key. This is redundant, but yeah, I'm clearing those things up. Then the program ID, by just creating this is fine program address basically. So that's how we're handling the seeds for that part. Then yeah, back to what I was talking about. So now we know what the size of the data is because we have specified it in the instruction handler. This is the size of the old data that we're sending from client. Yeah, we serialize that data as something we can use. So with byte mock from bytes, then we serialize the data, deserialize the data basically as something we can use, right? As this general instruction handler thing. So what else? What else? What else? So we're doing some checks. Check that the user is a signer. Check that the account to create is empty. So the account that you're creating should not have any data inside of it, or else it already exists. And why would you want to create it again? Then what other checks are we doing? Message. Do I have a message? Thing. So 1 minute. Test it. Okay. Then okay, find. So and we get the seeds also for the account because that is from module serialized data dot seeds. So dot seeds, we're expecting a dot seed because we have this serialized data here from ByteMock. So I get a seed from it. Then we pass the seeds here, and the creator is also a another seed that we're passing for it to create the seed. So just like in the test, right? Then we are creating the account. We are not creating it. We are finding the account. So find program address with the seeds and the creator ID. Get the bump binding. So this bump binding is this one. So we just use this seeds macro from Pinocchio to convert it into seeds, basic seeds. Like then we do signer from signer seeds, duo signer seed copy. So copy duo signer seed array. Then so we have the signers. Then we're making another check, another important check. We're checking that the PDA that was derived on chain is exactly the same PDA that was sent from client. Else, you know why? So we just want to do that. Then we create the account. So we create the account from creator. So the rent for the account also rent gets minimum balance of the size of data, then the owner, the space that data is, the space that the account will take, and the account. Then we provide the seeds for the account. Since you're creating a PDA, you have to provide the accounts for the PDA, and you have to provide the seeds for the PDA rather. Then we just borrow the data that was sent from client. If there's any data you're creating it with some data, the data that you're sending from it, we we just borrow it. We borrow it into the some first account, right? So we borrow all the data, then we we extend the data that are passing, the data that are passing, whatever data it is. So I'll show you how that works in a minute. Extend that data that are passing here, and we copy from site. I'll just pour it inside this account. We pour it inside this account that was created, right? And basically that's it. So we get the data blobs, bytes. We read from it and we just send it into another account. We send it into that account. We modify the data inside the account. Basically, we override data that is inside the account. Yeah, so that's the magic behind that. And what else? So let me show you how that works in action. So this is a test. So if you have an account that you are creating, let me look for that example. Okay, so create account. Blah blah blah. So we're creating this account, right? This account in your game, this might be a real user position that needs to be created, that needs to be stored on chain, right? So my position X is 24, Y is 12, X axis and Y axis data. So this my position is defined somewhere. It's just a struct. It's the struct of my position. My position where at now. I'm sure I passed it already though. Let's see. Let's see. Let me find this guy. 15. Wow. Yeah. We have this at the top already. So we have this struct for my position, which is taking the X axis and Y axis of a player. But the SDK does the magic to abstract all of this from the user now, right? So I'm breaking this down into something simple so you understand what's going on that build. Then we have a length of the position struct. Same thing, these two are basically the same. Then we can convert it to bytes. So each byte must gets the bytes of itself. So we convert it to bytes basically. So yeah. So let's get to testing for 5. Yeah. So we have the seeds to create with Birdie and the creator pub key. Then we compute the hash as a digest as a pub key. So the seed now is just this pub key that is as bytes, not a pub key, but it's a U8 of 32 length. So it's basically the same size as a pub key. So we have that as the seeds here. Then we specify the size of that here, and basically we create the instruction data. We're testing with lightest VM by the way. So this is the instruction handler discriminator. So that's the first thing in the instruction. So this is the discriminator. Next one is the length of the data we're creating, the length of the accounts that we're creating. I think I should be here. Yes. The data, the whole data that we're sending as bytes. Yeah, so that is here. Wait a minute. So data that we're sending as bytes, data to write to account as bytes also. Data to write to byte to account as bytes. Then what's the next thing? The next thing is the state data. So this one is the our module data. That is this general instruction handler. That is our own data, not that. So this is modules data. So this is module data. This is data to write to account. This is module recognized data. Yeah, module recognized data. Then we have this next one right here. That's the third byte slice on this instruction. So this is now the data I want to write to the account, right? So whatever data I write into the account, if you're writing that the position of the user is this. So all of this, not that, is that control shift set. Why do we have this here? Yes. So I want to do this. Yeah. So all of these are the instruction data as bytes because basically everything they are sending to the blockchain is bytes. Exactly. So now Mojo can serialize and understand whatever instruction is coming to it because it knows the discriminator, it knows to cut off the discriminator first, and slice of the data it can work with, and every other thing else to the length that was specified is the data you want to write inside the account. So basically reading from account, writing to account, reading from account, writing to account. That's basically the whole thing. Yeah, so let me show you what that looks like inside the SDK and how we've abstracted it away. Let me see. GitHub, Mojo, Mojo, demo, Mojo, demo, not this one. Yeah, this one. Yeah, this is the demo, this is not the SDK. I need the SDK before the demo. Um, okay, I'm going to git. I don't need to close this. I need to close this and just put in a tab. GitHub, Mojo, program with the SDK. I think it's this. No, not this one. Still cleaning it up though. So that's what I want to do on this call. I want to do the cleanup, right? Excel Mojo program, Mojo demo, not this one. Mojo SDK. Uh, naming conventions. Let me just check. Let me look for it here. It's another example, Mojo Rust SDK, Anchor Frontend, another example, Hydra demo, Pinocchio SDK. Which am I looking for? Yeah, this one. Muhaha. Found here. Yeah, this is what we're looking for. Yeah, right here. So let me start by giving some amazing shout out to the contributors on this project. First, we have this are not all of them, still two guys that have not made their PR, so they're not here. So to Neo Crypto Quant, Emmanuel, to Inspiration, to Kuldeep, to Shubham, to Indra, to Mahmoud. We have we still have two other guys, but let me check the names. A minute. Gojan is good. Yeah, Gojant and Ajish. Yeah, basically Gojan and Ajish. They basically have been contributing to other people's PRs. Like if someone makes a PR, they work on it, merge it, you work on what they've worked on. So, but we've not made their direct PR. So that's why it's still like this. We have a couple of PR closed before now, 14 closed. Blah, blah, blah. So it's been a lot of work trying to make this happen. But yeah, yeah, yeah. That's by the way. Shout out to my team members. These guys are amazing. These guys are on fire. So is this what I think it is? Okay. So we have inside the SDK. It looks it looks like this. It still needs a bit of cleaning up. Yeah, that's what I'm going to do today. Because already. So let's see where we start from. Start from world. Yeah. So what we want to achieve, plan to achieve eventually was to have a simple API like such. So we have a world, a, a, a dev can create a world, yeah. So you can get mutable reference to that world if it exists. Then you can write to the world. Let's say this is a state you want to write to this bed state, right? So you tell it what kind of data, what kind of structure you're passing to it. So let's assume we're passing a bed struct. As a bed. Let's assume we're passing a bed struct. I need to do this. Control C. Let me put this. Yeah, so I can easily look at it. Yeah. So assume we have this bed struct. So we can now tell the SDK. So this is some world and create this state which has this kind of struct, and these are the states to create with it. So it's just simple and straightforward. You don't need to then you're passing the pub key, then the signer. You don't need to understand how to write an account, visualize an account, store this, store that. You just an SDK that just works. An SDK that is simple and straightforward to use to create a game. So you have to focus on writing your game mechanics, writing your physics, and all of those stuff. You don't need to take the extra. You need to take an extra 2 3 months to learn and cultivate games. Right? So that's basically what we're trying to solve. See, trying to see their questions on X. I should be able to see that here, though. Yeah, yeah, minutes. Yeah. So yeah, so that is basically what we are doing. So we're creating a state, we're telling it what kind of struct is inside our state. So it just solves the magic block. It solves the magic block. It solves the magic block. Solves the anchor learning curve. Yes, for game developers, just want to use. If we're coming to Unity, also build a C sharp or a C plus plus or a C sharp SDK to interact with the program. So to be something as simple as straightforward as this also. This is basically still tested in Rust, Bevy Rust. I'll do a demo of that 1 minute ago. Let me explain what's going on that before we get to that. So create state, bird, the seeds for it. Then if you want to read the state, this is basically what's going on there. Basically what's going on there, right? So we have if it's a cat also provide the state the struct of the cat, serialize it inside. It's just simple. So we're not doing this. We're not doing this. No, let me do a comment in front of it and say, no, we not do this. We did not do that. Comment. I need to be, I need to emphasize on the no. Nah, we don't do that. Yeah, now that that's out of the way, let's do this. Yeah, we are not synchronizing it because we are doing the delegation and not delegation inside this instructions here. I'll get to that. But before then, let's see what else. That's pretty much how it works on this from surface level, right? So let's now have our teeth inside the SDK. Yes. So we have this struct world. So the creator and the seed. We have an implementation of the world. Create world. Find world PD is an helper. The seed hash, like I explained. So you are creating the instruction is another helper function. It takes in the pair, the word PDA, the seed hash, and the byte of the account they are creating. So we are creating the account. No create world. We already know what size, what data the world should be in. So that's why we are creating with this byte of world. right? Yeah, so that's basically what's going on there. Then we send the instruction over the client and we get the world PDA back once we're done with creating the world. So the second thing is what I demonstrated, that create state. So we are passing in a module state. Module state is just a trait that implements pod, zeroable, and copy. So we could do where we could use T where T is module state blah 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 blah. But just this works too. Simple. I'm a fan of simple. I'm a fan of simple. Simple should work. Yeah, so this is what it is. Implementation module state for T, where T is for pod, plain no data, zeroable, and copyable, right? So creating the state is still the same instruction as create word. It's just creating an account, right? Then we are going to clean this up. Also, then after we created the world instruction, we want to create the delegate account instruction also. So we created, we're not creating the world, we're creating a state account. And we're delegating that state account once that's been created successfully. These are the instructions for that. The first instruction is send over the client, the create instruction, then send over the delegate instruction. But why didn't I just put a comma here and add this delegate instruction at the end of this? Who knows? Yeah, nobody knows, right? Okay, so the right state is modifying is basically similar, but we're writing, I just writing what states or modifying the states basically. So, yeah, I don't need to go into the technical because of that. Then reading state is same thing. We know what state we want to read. Then we return the state as that kind of data that you provided. So the data length, and we return that state. That's a good of us. So then just let's get to the what everybody's waiting for, right? Everybody's waiting for to see how it works. Yeah, yeah. Let me see. Let's see. Just see. It's still laggy. Documents. Moving. It just did a moving character. And shout out to all the contributors on this project also. Again, you guys have been super amazing. Moving game, then code moving game. This game is written with Bevy, by the way. If you don't know what Bevy is a Rust SDK. Bevy Rust. The Rust framework, either you say SDK, is a framework for writing games in Rust. And it's easy. It's not, it takes a lot of getting used to. It's new. It's something you are going to be new to. You need to understand how the primitives work, how the APIs work. Right? So I'm still new to Bevy also, but building this SDK has made me get my feet wet around it. Right? So let's show and tell. Let's show and tell. Show and tell time. Yeah. So what I need to do first, I've used these seeds previously, so I'll just update these seeds. Let's call the character at position 13. 13. I think one more, like three seeds. But yeah, 13. Let's release 13. So this will be inside your game, right? This one is the new world create world, then seed for other things along the line. Should I explain before I show? Or should I? Let me just show. The tension is high already. Like, yeah, yeah. So let me clear terminal. Then I'll just do a cargo run. Cargo run. Should take a while. Just bear with me. This is local. It will take. You'll see something not responding a lot because it's local, right? So yeah, like I said, VS Code not responding, but it will take a while. Let's wait. You can wait. We are not in a hurry. Wait, wait. Everybody loves waiting. Yeah, 1 minute. I think I need to plug in my PC real quick. Forgot to. Yeah, so and if you check the logs right here, we can see this state here. We got a world that is, and we also spawned the character position and delegated the character Then we need one more state. We created three states: the world, the position of the character, and the health of the character. So give it a minute. Let it load up. 1 minute. 1 minute. 1 minute. Eh, bro, up with me. This local is RPC connection that's taking this long. Yeah. So we have a character on the screen, and we created the health of the character, right? And we are syncing the position of that character initially. Wait for it. So now if I move the character around, if I stop movement, you see the health is reducing. If I stop moving, you'll see so in a minute. I sync the position of that character and I sync the health of the character on the ER on the femoral roll up, right? So let me check this in the logs and make this visible all the time, always on top first. Let me copy this to see the position that we just synchronized on chain. We still have the logs there. So I think so scan. Yeah, so scan. Then I'm on the EU validator for Magic Block. Yeah, I think it's this one. Same. So if I paste that transaction hash over here, I paste transaction hash over here, I should see the transaction I went through. Yeah, transaction went through successfully. Complete unit 2203. This should reduce when we remove the log. So and all the accounts that was this was first time it was created, the account that was interacted with. So this was the initial position. So let me move this character one more time and see. Let's check the logs. Yeah, have it updated? Yeah, it's updated. So let me copy this one, and I will come over here and paste now. So you see the changes that was made on the account state. Yeah, so now we see I thought everything is bytes, right? So this is the new data which represent the position that this character is on the screen. So let's check for the health also. The health is this one over here. Let's check this real quick. So before I get into explaining how the code works, and I'm not the best person to explain how Bevy works, right? But you will to understand. So this is the health of the character, 70 and 30. That's bytes. So this is what is going on under the hood. Let's pop the truck. It will be. Let me remove this 1 minute. Okay. So this is the entry point again. Excuse me. Sorry. Like I said, I'm not in the best position to explain Bevy, but I'll just do my best. I think I understand what's going on to some extent. If not, I'll not be doing this demo. Yeah, and yeah, this is Shubham's branch. So there are a number of things that I'm not up to sync with. Yeah, Shubham made this changes. Yeah, so let me just go into the parts that I think I can explain. The resources. Okay, resources is what we're doing here is this is the old game state. So for a demo, we are having a key pair that's created inside the game. So the position of the state name, blah blah blah. The position of the character is a struct my position. The health of the character is a struct my health. The RPC, the RPC. But now we're going to abstract this. So you just specify devnet or mainnet. Inside the SDK, we'll switch between ER or base layer. Yeah. So last sync timer is like I demoed. If your character is moving, now if the character is moving, once it stops moving for a sec, then it updates on the ER. Yeah. So that's what last sync timer is. It gives you time of that. So states. Okay, gaming. So if the game is still playing, or game is over. Systems. Yeah. So that's this is the meaty part of it. We have the world. We created the world. We initial position of the character. Like I said, we have the initial position of the character and initial health of the character 1000. It's also a struct. So this is what the struct definition is. I think it's under here. Is it under? Has it moved it away? Wait. Yeah, I think I know. It should be inside states. I think not states. It should be inside components. Yeah, I guess components. So yeah, this is the health of the character, the current health, the max health. So I think when we check this, you should see current health. No, this is blob. This is not exactly that's what you're looking for, right? But this is the current health, max health. Then we have the state of the current player struct. It contains the size of what do you call it, the position of the player. I'm looking for that component. Where did you put it? Where did you put it? Where did you put this component? Where did you put the component? So let me look for resources. Let me look for I think it's in resources, yeah. No resources systems. Let me see. Let me see. Order state, game state, where the user position. So now right state, game state dot position, game state dot position. Oh yeah, this is the position of the character, and position of the character is from here. So the position of the character is this, and the health of the character is this struct. So this is basically just what you want to save the types, and this is what our SDK is working with, right? So you just have to specify that it is debuggable, copyable. The debug is even you can ignore that. Clonable, zeroable, plain old data. These are just basic macros that I specify on top of your struct. And you're good to go. You automatically created an account when you push this on chain. So compared to how you'd have to do it, I think here. This one create the components, copy and canvas. Okay, component. The component macro is hiding all of um, the visualization thingy. We could do that also, so you have a clean. Well, that's deriving copy. We could have done that. Well, that's not that's not my problem. I did not write the both SDK. Yeah. So back to what we're saying. The position, whatever data you're saving, it's just plain old data. Save the data and update it. So yeah, yeah. If you want to get into more detail on how it works, the link I can share it or just wait till after demo. We have a demo on Wednesday as a graduation ceremony at Turbine Accelerated Leaders demo. And we will share that. Maybe after that, we can now share a proper demo of how it went and we get into we're opening up to other contributions. If you'd like to implement this in, if you have proficiency in C sharp or C plus plus for Rust, for Unity or Unreal Engine, whatever gaming SDK you want to implement this in, if it's in Lua, you want to write a game in Lua, you need a Lua SDK that can help you interact with Solana. You can contribute to that. If you want to write your games in wherever you want to write your games in, right? So there should be an SDK that can help. You should you can contribute to create that SDK. You want to build an SDK in Flutter. You want to build games in Flutter. You want to build games in React Native. To build SDKs in TypeScript or that to help you interact with this. So it just gives a unified and simple entry point too. So other things we might want to add on top of this is uh, incentive. So if you want to do some introduce incentives in your games, tokenization, all the stuff. Yeah, this SDK should be able to provide that. So create a token, an NFT, who wants this NFT, mint an NFT, all those stuff, all those good stuff are the things we'd like to be adding on top of the SDK. Yeah, so that's basically it for this. If you have questions, can drop while I go down the rabbit hole and try to fix the things that I was supposed to fix on this. Yeah. So that's basically what we built. If you like to contribute, please contributions, please. This is open source. After our demo, right? Let's demo it first and feel good about what we've done so far before you make contributions. Yeah, so that's basically it. I'll just try to clean up. What I have to clean up basically is if I check the systems, the world drive states, these guys. If you enter the SDK, find what VDA, I need it to be so that wait 1 minute. Source source world. So I need it to be so what am I looking at? Oh, I'm in the world exactly. I need it to be it should be inside the client. Let me check. Client source client RS. Yeah. I need it to use just expect you're telling the SDK, am I on DevNet or am I on mainnet? Mahmoud started that in his new, yeah, Mahmoud did that in his new PR for the sound to clean it up and test it with Axel Mojo branches, branches, get me branches, open it, yeah, in the SDK. So in his lib, not lib client, I think client, is already doing that here. So if user is specifying their own main, do this, they are specifying their own dev, do this, and yeah. So he has more types, there are more Rust docs on it. So this is a good looking SDK, good looking PR for the SDK. So he explains what's going on and how to use it. So there's still a lot of cleanup to do to move all of this or to merge the PR, test it, break it, and make it stable. But I would like to do that after after the demo. Because I can't start merging. I start fixing this now, and this does not work. I'll just start. I'll start a different. I'll work on it on a different branch. So at least everything will still be working fine for demo. So again, let me make the user run out of life, and you see the end game. So this should have updated the ER now. Yeah, updated the ER now. Then remove. Okay, I just did. Yeah. So now remove, keep moving, yeah, keep depleting, keep moving, game over. You want to start the game, start again from all. So yeah, that's basically about it. So you can now build it up, you can now build complex stuff on top of this simple illustration that we just did, right? And this example, you want to look at demo Mojo. So if you want to look at Devi, want to try it out, there is a good YouTube resource for beginners. There's this guy that does good videos on Devi and he updates it every time there's a major update on Devi. Let me look for the playlist YouTube. Yeah, Devi. This guy. So he has a playlist I can go through. There's logic projects, cool guy. The example I did was basically from this example. So you see a lot of similarities in I think he started with. At the end of the game, at the end of it, should have yeah. So yeah, so the only difference is mine is green. I use the exact character. Mine just has a green background and that's this health bar. So the health bar I still did resource other examples on how to do that stuff. Yeah. So you could just if you are new to Bevy, you can check him out and yeah, cool, cool. I so we are just 1 hour 4 minutes. Let's see, should I start ripping or should I rip outside live stream? Let me see. To rip online, to rip offline, to rip online, to rip offline. Do you guys want to see me jam and tear this out? Yeah, break this down. First, first three comments win. So if I have two yeses, two yeses, and one no, I'll still be online and try to replace it. If I have two no's, I'll just go offline. I'll fix this. Let's see. Let's wait a minute. What is going to be? What's it going to be? Chat. What's it going to be? Chat. 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 To rip online. To rip offline. To rip online. To rip offline. Nobody has responded yet. So I guess I should rip offline. Let me see. One more minute for people to respond. And if nobody responds, I just go offline and face the music, trying to clean this up. Yeah, I guess that's basically it. All right, guys. Thanks for your time today. That has been me ranting and explaining what we are cooking for game developers in Solana. This has been the 1 minute. I was losing this guy. So this 1 minute still hold on. Yes, this has been the Anchor founder. The Anchor founder, and thank you for joining. See you on the next episode. That will be Wednesday. And I hope it's not the same time as my demo. If it's the same time as my demo, I might do it earlier or later. Who knows? Yeah. So thank you. Thank you. See you on the next one, guys.